Good evening, everyone. You are welcome to today's section, Data Analysis. You are all welcome to tonight's section. Tonight we will be looking at data analysis as it concerns regression analysis, correlation analysis, and then we will wrap it up with descriptive analysis in Microsoft Excel. We will start from explaining what is regression analysis, and we will move to what Alright, let me know if you can hear me, if you can see my screen. You are welcome for tonight's section. Then we wrap up with descriptive analysis. Tonight we will start from explaining what regression analysis is all about, what types of regression analysis, what are the key concepts, the key components, what is the statistical significance, what is the null hypothesis and the alternate hypothesis, and that's why we will be using them. And then we will be looking at some use cases. We will look at running some analysis as regards to regression, and then we look at also as regards to correlation, and then we wrap up with descriptive analysis. Once again, you are welcome for tonight's section, data analysis. Tonight we will be covering regression analysis, in-depth regression analysis with use cases. We move to correlation analysis, and we will wrap up in this week's session with descriptive analysis. Once again, you are welcome. Let me know if you can hear me. Let me know if you can see my screen. Let me know if you can hear me. Let me know if you can see my screen. We are live again for this night section. Welcome to 2025. We started this scholarship program last year, December, and today we are in week 3 of the scholarship course, and we are remaining 3 more weeks to go. So let me know if you can hear me. Let me know if you can see my screen. We are live once again tonight. All right. You are welcome, Victoria, once more. Yes, you can hear me, you can see my screen. Beautiful. Go to the scholarship group, go to the data analysis scholarship group, type there, let everyone know we are live. As our tradition is, your name and your scholarship ID, your name, where you are, your location, and your scholarship ID. If you are joining us, you remember to drop your name, your location, and your scholarship ID. Welcome once again. Welcome once again. We are going to in-depth analysis this week 3. We are going over, we will be looking at the regression, correlation, descriptive, and then we will wrap it up with the Power Query aspect. All right. Thank you guys. Okay. Yes, your name and your scholarship ID, please. Very, very important. Scholarship ID. Attendance to this course is mandatory for one to be awarded the data analysis certificate in Excel. One must be in attendance. All right. Okay, you are welcome. All right. Let's get straight to what we have today. Let's quickly move into what we have. We will be starting with regression analysis this night. If we're able to complete it, we will enter correlation and then we wrap up with descriptive analysis. What is regression analysis? That is what to be looking at tonight. And then we move from there, we move to what is correlation. Because we need this in business analysis, is needed in research analysis. You are writing research papers, you are doing business analysis, your day-to-day analysis, you need the regression analysis so as to look at factors. What are the factors that are influencing decisions and what are the factors that are having to bring about relationship? All right. Now, regression analysis. What is regression analysis? Now, we said that regression analysis is a statistical technique, or some will say is a statistical tool. Is used to understand and model. Very, very important. Is used to understand and model the relationship and influence. These two key things are very important in regression analysis. In fact, these are the two major use cases. These are the two major or the two main use cases of regression analysis. Is used to understand and model one relationship. What is the relationship between two variables? Between two variable, a most dependent variable. And then to check influence. What influence the independent variable has on the dependent variable. That is the main use case. The main use case of regression analysis is used to understand and model the relationship and influence. The influence can be called effect. You can use it. You can replace influence. You can replace it with effect. You can replace effect with impact. The relationship and an impact or effect or influence the independent variable has on the dependent variable. So regression analysis is a very important statistical tool in the hand of every business analyst, in the hands of every researcher. You need to understand effectively how you can model to use regression in order to predict. Regression analysis is also use it to predict outcome of events. We use it to predict outcome of an activity, and also we use it to check the effect, the influence a variable has on the other. For example, you graduating, there are factors that are involved in you graduating as from the university, secondary school, graduating from masters, MBA, whatsoever it is. There are factors that influences that you graduating. Now, what regression analysis does is to help us pick those factors, those key factors, those factors that plays a major role. For example, going for lectures are one of the factors that influences your graduation. Going for lectures are part of it. But is it a key factor? Some might say yes, some might say no, depending on the structure or the setting of the school. You might not attend lectures and you come to the exam hall, pay your school fees and wrote your exam and pass, you graduate. But going for lecture is part of, is a factor, is an independent variable that influences your graduation. But you not writing exam, which is also a factor, but this one is a key factor. That is where we will be looking at the level of significance. So in regression analysis, we use it to check what factors are significant and factors that are not significant. That is where we will be looking at the null hypothesis and then the alternate hypothesis. Where the null hypothesis, there is no significance. The alternate hypothesis, there is significance. So this is the first thing we need to understand. The essence of regression analysis is to use to predict outcome of event, and then to use to check, to use to ascertain, to verify the influence of the independent variable, the what we can call factors, or what we can call predictive predictors or explanatory variables. What explains the dependence? So this is the foundation of what regression analysis is all about. And there's, like I said, is an important tool. You use it to model equations, to model strategies, to see if this medication for those in the healthcare, whether this medication has effect, has a significant impact on the patient's recovery, or whether this business strategy or whether this marketing strategy has a significant impact on our revenue. So you need regression to check. You can use it to predict what your revenue can be in the next 6 months. So is a very powerful tool in the hands of every business person, health specialist, customer service, real estate personnel, different fields. Now, having established this fact, we will now move to the aspect to which we refer to as the key concepts. The key concepts. What are the key concepts in regression analysis? What are the key factors, the major stuff you need to bear in mind as regards to regression analysis? Remember, if you are joining us, remember to drop your full name and your scholarship and the scholarship ID. Very, very important. Attendance to class is very, very important. Remember to drop your name and your scholarship ID. And if you are joining us and you are not part of the scholarship, I will encourage you to hit the subscribe button, hit the notification, because we go live. We have series of trainings coming up as regards on this channel that we make live public to anyone that wishes to attend. All right, now what are the key concepts? What are the key concepts in regression analysis? The first is the dependent variable Y. Those of us in basic mathematics, in the basic calculus, we have the dependent variable Y. In other words, this variable depends on another variable for its outcome. A variable depends on another variable for its outcome. One can say you being healthy depends on how you feed. You being healthy depends on the kind of environment or the kind of weather or the environmental factors. Different stuff that you being healthy, one can say, depends on the way you eat, the kind of food you eat, the kind of work you do. There are factors. So your health is, we can say your health is dependent on some factors, on some variables. So that health becomes a dependent variable. Now let me break it down. Your sales depends on whether you have customers that buys or not. So sales is a dependent variable. Your customer's patronage is independent. What causes the customer to buy? What triggers the customer to buy is independent. I'm trying to lay some emphasis. I'm trying to broaden our concept, our understanding, to what we refer to as dependent variable. Whatsoever that depends on another in order to get its outcome in order to get its feedback is dependent variable. So the first key concept you must understand in regression analysis is the dependent variable. And what's a variable? We have explained what variable is in the introduction to data analysis, and if you have not gotten that, go down to the channel, check it, go through the introduction to data analysis. We did justice to that, what a variable is and what a constant is. So go ahead and get it there. We have dealt with it and did justice to that. Then number 2 is independent variable. That's number 2, independent variable. Now, what's an independent variable? Independent variable is a variable that can stand on its own. Let me put it that way, in a simple term, in a layman language. It can stand on its own. Nothing influences it. It influences stuff, but nothing influences it. The independent variable, it can stand on its own. The customer can be on his own. The customer can be on his own, but the sales depends on the customer. For you to make sales, you need a customer to buy your product, your services. For one to be healthy, one need to eat right, one need to exercise and stuff like that. And for you to being the drug that is being administered is independent. The treatment strategy, the treatment model, the treatment techniques that is being administered to the patient is independent. Whatsoever that does not require extra input for it to function is independent. That's what we refer to as independent variables. And in the Cartesian coordinate, we refer to independent variable as x, but it can be anything. You can call your independent variable anything, but we use x and y to denote the independent variable and the dependent variable. Then the thirdly, which is the regression equation. Now I need to state this, that the regression equation is simply the equation of a straight line. Those of us that did trigonometry and maybe a bit of calculus, we understand the equation of a straight line. The equation of a straight line is simple, equals to y is simple equals to, when we talk about equation of a straight line, the equation of a straight line is simple. We can say equation of a straight line is simple, y equals to ms plus c. This is what we call equation of a straight line, and this equation of a straight line is what we refer to as the regression equation, where y becomes the dependent variable and x is the independent variable, and then the m, which in a straight line we call it a slope. In regression we refer to it as the coefficients. When we get into the practical aspect, running the analysis and then interpreting the results, you begin to understand what we refer to as the coefficients. And C, which we call the receptors or the y-intercept, is a result where there is no dependence, where we don't have any independent. In other words, where the independent variable is 0. That is the value we have. So these are the key concepts, of regression analysis. All right. Now, having said that, we proceed. Now, having said that, we will proceed to the next slide. And that is types of regression analysis. what are the types of regression analysis. In the field of regression analysis, there are different types, but tonight I have summarized 5 key ones. I think 4-5. I think is 4-5 key types of regression analysis. 4-5 key types of regression analysis. The first one is what we refer to as simple linear regression. Simple linear regression. Now, what is simple linear regression? Simple linear regression is explained or defined as a linear regression with one dependent and one independent. I repeat, simple linear regression is a linear regression with one dependent and one independent variables. So when we are talking about an analysis or a data set, and we are looking at one dependent and one independent, then is referred to as simple linear regression. Simple linear regression. That the equation of the straight line we wrote before, which is y equals to mx plus c, can be called the equation of simple linear regression. We can call it the equation of simple linear regression. I know why I'm laying this emphasis this night, because there are certain things, if we don't understand, if we don't know, in the interpretation, when we begin to interpret the result of the analysis, most of us will be lost. So that's why I'm taking a bit time to lay this foundation for us to understand what we are doing. Because the key to analysis, when I teach my students, I will always tell them, some of them are in this scholarship course. When I teach them, I tell them that the analysis, the key aspect in analysis, the major aspect in analysis is the ability to interpret the result. That is where you know a person that is an analyst. An analyst is not one that enters data. You can call that person a data entry specialist. An analyst is one who can analyze data and interpret it. That is whom an analyst is. And for you to effectively interpret the result from a data set and use it to predict, and use it to draw insight, and use it to analyze trends, you need to master and understand the basic ideologies, the basic terminologies, and the basic foundations as regards to each tools that pertains to analysis. I'm going deep. We are now heading deep into analysis. The first 2 classes we had, the first 2 weeks, is to give us foundations, for us to be able to master Excel, for us to know functions and do certain basic analysis that refer basic analysis. Now we are moving into some deep analysis. After this, we will be looking at Power Query, then we can begin to use pivot tables and the likes to begin to do certain stuff. So simple linear regression is a regression analysis that involves one dependent and one independent variable. That being said, the second one is what we refer to as multiple linear regression. Multiple linear regression. In fact, the first and the second is mostly the commonly used regression types around. The linear, simple linear, and the multiple linear is the most commonly used. So what is multiple linear regression? Is a regression analysis. Is a regression analysis that involves one dependent and more than one independent variables. In other words, it involves one dependent and 2 or more independent variables. So for us to bring the equation of a straight line, for us to look at, for us to write the equation and to say it more, I will put it in this way. I will put it in this way. That y is equals to m x 1 plus m s2 dot m s n plus c. This is the equation of multiple linear regression. So what you have here is a dependent variable that depends on these variables for its result. The x1 variable, s2 variable, up to xn. So it can have as many independent variables as possible. It can have as many predictors as possible. It can have as many factors as possible. That is what we refer to as multiple linear. And one of the things we are doing is that we are going to see how we can run a linear regression in Excel. So we refer to it as multiple linear regression. That is the equation. That's the equation for multiple regression. That's the equation for multiple regression. Now feel free to drop any message or any question in the chat box. Feel free to drop it. The next one is what we call logistic regression. Now, what is logistic regression? Is a regression that involves categorical data. Now, this categorical data is a categorical data that involves yes or no. When you say, are you a male or a female? That is categorical data, yes or no. Now, maybe you are looking at will this strategy boost our income positively or negatively? Will this strategy affect our income positively or negatively? When you are running analysis in that line, it is logistic. From what we call logical functions, we have done logical functions in Excel. When you talk about the true, if it's true, give me this. If it's false, give me that. That is also an aspect we refer to as logistic regression. When we are looking at a strategy, a marketing strategy, a selling strategy, a management strategy, maybe as a HR, you are testing different human management strategy to see the one that will be best, to know will this affect the staff positively or negatively. Will this affect staff productivity positively or negatively? Once there is criteria of yes or no, once it will involve yes or no, it will affect employees positively. If it's yes, if it's no involves, once it involves yes or no, it's a categorical statement. And what we do is logistic regression. That is what we have. All right, let's proceed. The next we have is polynomial regression. We all know what polynomial is a regression that is in the power of 3 and above. Is no longer linear. Linear, if I'm to explain, linear is an equation with the highest power to 1. Linear is equation that has the highest power of the unknown is equals to 1. That's linear. Then polynomial, once is from 3 above, that we refer to it as polynomial. So a polynomial regression is that regression we model of stuff in the power of 3 and above. Then we have nonlinear regression. Nonlinear regression. There is no normality. There is no linear. Is the opposite of linear regression. That's the opposite of linear regression. That is the key types. There are other types that those ones are not commonly used, but these ones we have, you can one or two occasions see the nonlinear regression and then the polynomial, but the mostly is the first 3, the simple linear, the multiple linear, and the logistic regression. All right, now having established that fact, we will proceed to the next aspect we have as regards to tonight's section. Let me know if you are getting value for this night. Be free to drop it in the comment section if you are getting value. If you are getting value, drop it in the comment section. Let me know if you are getting value tonight. Drop it in the comments, in the chat box. Drop it, feel free and drop it in the chat box. We are still moving powerfully forward. All right. Now, what are the assumptions you must make? What are the assumptions that has to be satisfied or has to be made in order to use a regression analysis? What are the assumptions you must make? Not that you should make or you might make. What are the assumptions? These assumptions has to be followed, ascertained, and believed that is true for us to use regression analysis. Number 1, linearity. We must assume that the data is linear. In linearity, when we get practically full, I will be explaining a kind of linearity. Then let me go to word independence. That the data sets are independent of each. The independent variables has no kind of relationship with the other. That we have to assume that. Then the same one, we have to assume normality, that the data set is normally distributed. I'm not here to teach statistics, but in statistics we know what those that understood statistics a bit, you understand the normal distribution curve. You understand the normal distribution curve. All right, thank you. All right, now that we have to assume that the data set is normally distributed. Then the 4th one is to assume the homostaticity of this data set. I will explain that when we get into when we begin to run analysis practically. I'm laying foundation tonight. I will explain that what the homoscedasticity is all about. This statement is, or this word is always difficult for me to pronounce. I don't like pronouncing it. It's always difficult for me. All right. Now the next one is no multicollinearity. That in the multicollinearity is that the independent variables doesn't have a kind of linear independence with each other. So these are the assumptions that must be met. If you are to meet these assumptions, then you can run regression analysis. You can use regression analysis. And that is the foundation of regression analysis. That is the foundation of regression analysis. Now, I don't want to go to correlation analysis to lay the foundation as well. I don't want to go into that. What I want to do this night is for us to look at the simple linear regression, the multiple linear regression, which is the mostly used or the one you will mostly encounter in your workplace, in your research, mostly in your business. This is the one you will mostly use, the simple linear and the multiple linear. That's the one you will mostly use. Later we will also look at the logistic linear the logistic regression. Those three very important. So I will not want to go into the correlation analysis to begin to lay foundation of the correlation analysis. However, there is also an aspect of correlation in regression, because regression also checks for relationship. Regression also checks if there is a relationship between. That's regression. It also checks for relationship. That is why I need to state this. When I teach SPSS, when I teach my students SPSS, which is also a data analysis tool, especially for research and kind of social science, when I teach them SPSS, regression analysis and correlation analysis are what I grouped under the subject called relationship. I grouped them under the subject called relationship. Regression and correlation under the subject called relationship. And there we have simple regression, we have multiple regression, we have simple correlation, we have multiple correlation. We will still get to that. So here I will pause here and move straight to Excel for us to see how we can run analysis, how we can run regression analysis using Microsoft Excel. Some persons might think, some persons have thought maybe regression analysis can only be done maybe in SPSS, Python, or Arrow, or Software. We can also do it using Microsoft Excel. All right, let's head straight to our Excel. Okay. Now let me open my Microsoft Excel. This is the data set we have been using, and I'm going to be using this Now, before I proceed, before I decide on the data set to use, I need to state this. When you are to run analysis, you don't run analysis on strings. There is what we call strings. You don't run analysis on strings. Please note that. You don't run analysis on strings. In other words, when we run analysis, whether be descriptive analysis, regression and all that, we run analysis on numbers. We run analysis on numbers. Analysis are not run on strings. In other words, what are strings? All these text, characters, they are strings. We run analysis on numbers. Numerical data. That's what we run analysis on, numerical data. So when we get to run analysis, we need to use the numerical data to trace event and see what we can talk about as regards to that. Okay, now we have this data set before us. We are already aware of this data set, which we are going to be using to run some regression analysis, from simple regression then to multiple regression, and if time permits us this night, time should permit us, we are going to do some interpretation, interpret the data set, interpret the results. And to interpret the result, that will take me to explain certain things, like that has to do with the null hypothesis, that has to do with the level of significance, that has to do with confidence interval, as the likes, the coefficient, and setting up the regression model is something that is easy, is something that is simple to do. All right, now for us to run a regression analysis, now we want to check we want to look at whether the units, of course it should, of course, whether in this our revenue, selling price per unit, the number of units sold, these two are the key factors that influences our revenue. Because as an analyst, it is your responsibility to determine what's your dependent variable and your independent variable. So in this data set before us, next time I will also bring certain data sets as regards to other aspects so that we understand effectively. Now, as regards to this, the revenue generated, the aspect of the revenue generated is also the revenue generated depends on the selling price per unit and the number of units sold. So if we are to run a regression analysis to check the effect or to check the relationship between the selling price per unit and the revenue, to know if they are significant, if the impact of selling price per unit on revenue is significant, if it has a significant impact on the result we have here, if it has a significant impact on this result, that is simple regression when we are considering only these two, where the revenue is the dependent and the selling price per unit is the independent. In that case, it's a simple linear. In that case is what we refer to as simple linear regression. That is what we have when we are considering. Now when we now consider the units sold, the selling price, the effect, the impact, if there is any relationship, if there is any effect, impact it has on the revenue, that becomes multiple. That becomes a multiple regression, a multiple linear regression. Multiple linear regression, that becomes that. So for us to do that, let me delete this. Now for us to run the regression analysis, some of us might look at, there is no regression here and stuff like that. You go to your data, go to data, you will see this called data analysis. Now I now need your feedback. I need feedback from you now. This is, we are going to be doing certain things live. I will need feedback from you. If you are with your PC live, with me here, type in the chat box, I'm with my PC, and let me also know the version of Office you are using, whether it's Excel version 2021, 2024, 2019, 2016, 2013. I don't expect to see 2010. Forgive me if I'm blunt, but I don't expect to see someone using Office 2010. I don't expect it. So I need your feedback. I need you to reply to me. I need you to reply to me. What version of Office are you using for this live session tonight? Let me know. And so that I will know if in your office you have this data analysis tool, because that is what we are going to be using. Let me get your feedback. I need our feedback tonight. Okay, now if you are joining us, remember to drop your name, your scholarship ID, the location, very important. Exit 2013. Okay, I'm not sure if that too might be there, but I will walk us through to see where we can get it. Okay, beautiful. Version 2021, beautiful. Now if you in your Excel, if you come to data and in the data you didn't see data analysis here is not there in your Excel. Can you confirm? Please let me know. Those of you with your PC, beautiful 2016, those of you with your PC, let me know whether you have these two present in your tab, in your ribbon, under the data tab. Let me know, please. I need us to work with me because it's very important, so that I can help you to activate it right now. If you don't have it, let me know. Do you have this? Go to data, click on data, under data tab, come to look for this data analysis tool here. If you don't have it, let me know. I need us to respond, please, because we are going to be using it for our analysis to run regression. I don't want to use function. It's just something simple for us to do. I don't want to be using the regression function in Excel. We have used function a lot in this course. We need to be using stores. All right, someone said no. Okay, your 2021 piece, okay, version, all right. Dockers, okay, you said no, you don't have it. All right, okay. Now, those of us, if you have it, beautiful, that is awesome. And for those of us that don't have it, let's go. Follow me right away as I go with me. Now go to file. Go to your file. Under file, come to this place with we have options. Locate your option in your back office file. Go to locate this option here. Go with me right away. No, it's not the same as what if analysis. I'm still going to talk about what if analysis in this course. It's not the same as what if analysis. It's different. It's not the same. So if it's not there, then it's not there. All right. Go to file, locate options, go to options. I'm waiting for everyone to be able to be there. Go to option and then click on options. This dialog box will appear. Once you click on your options, this dialog box will appear. Go down here to add-ins. Go down to this place, go down to add-ins, go to add-ins. Under add-ins, come down to this place. You see this called manage and you see Excel add-ins. You will see Excel add-ins. Under the Excel add-ins, click on go. Now once you click on go, ensure that you activate your analysis tool pack. That's what it is. Analysis tool pack. Ensure you activate it. Mine is activated. If you are there, let me know. If you are there, drop it in the chat box. Let me know that you are there. If you are there, let me know. If you are already in this place, let me know. If you are there, let me know. We need to get this. We need to get it. This is not theory. We are not speaking English here now. This is no longer English. We are no longer speaking GST now. We are now in practical stage. If you want to learn analysis with Excel, you will be baptized unless you don't want to learn, unless you don't want to know. Mr. Franklin is ready and willing and steady to baptize you with Excel analysis. I have been analyzing with Excel and other tools for many years. I can guarantee what I'm talking about. Beautiful. Yes, I'm there. All right. If you are there, ensure that you select it. Let it be marked good. Click on it. It will be marked good. Yes, the one you are to select is the first, the analysis 2 pack, not the one of VBA. You can also check the two of them if you are to work with Excel VBA and you need analysis 2 pack. VBA is Visual Basic. Do you want to write codes in your Excel? That also, but you can select the two. But if you are not using Excel VBA, you select the analysis 2 pack, the first one. Yes, I select the first one, or you select the two, any of them. So once that is done, you click OK. You click OK. So once you click OK, you go to your data. You will see your data analysis 2 pack. You will see your data analysis 2. You will see this. Are we there? Respond, please respond. Go with me. Respond if you have activated yours. Let me know. Let me see it in the chat. If you have activated yours, drop it in the chat. Drop it in the chat. We have entered into the baptism of analysis. When later we will be looking at use cases as regards to the correlation, as regards to regression. We will be looking at use cases on Friday. We will be getting to do different aspects of use cases. Let me know if you have activated it and you are able to see it on in your Excel. Let me know. Drop it in the chat box. All right, beautiful. Shola, yes, beautiful. Let me get our feedback. One person already has said that. So that I want a good number of us to go alongside with me as we progress. Beautiful, Dorcas. All right, beautiful. 3 persons already there. Okay, now what we are now going to do is this. Just anywhere here is okay. Just you click anywhere here with me. Go to the data analysis. Click on the data analysis. You will see a dialog box that will pop up. These are dialog box 2. You will see the ANOVA. Those of us in analysis, you see the correlation, you see the descriptive statistics, you see the exponential smoothing, the F-test, the Fourier analysis. There are different aspects of analysis. The t-test, if you are into research analysis, the t-test, or the t-test, the independent t-test, the paired sample t-test, and the likes, they are all here. So we are going to select this regression. We are going to select the regression. Click on regression and then you say OK. Now once that is done, this guy will pop up here. This dialog box will pop up. What you will need to impute, you will need to impute your Y range. And what is your Y? Your Y is your dependent variable. Your dependent variable is your Y. Now that is the one we are going to select. That is your dependent variable. So we say Ctrl Shift down. That is the first one, the dependent variable. Then we go to the range of the independent. For now we are running simple linear. Simple linear, one dependent, one independent. So we go to this, controls down. What did I press? Ctrl Shift down. All right, that's we select. Okay, then we have this label. You need to highlight the label. I think you need to highlight that. You need to select label. If your confidence interval is not 95, What is the confidence interval? The confidence interval is also synonymous. It has a relationship with the significant level. Now, if your confidence interval is 95%, that means your significant level, your significant standard is 0.05. I repeat, if your confidence level is 95%, that is to say that your significant standard, your level of significance is 0.05. And what is level of significance, or level of the level of significance is what you are going to base your result, the criteria to which you are going to compare your result to know if you are going to accept the null hypothesis or reject the null hypothesis. I repeat, your level of significance, the significant level, which is the general standard in social science, is 0.05. But in the medical analysis, health analysis, mostly is not 0.05. It have a higher significant level, higher confidence interval. It might be 99.9%, which makes the level of significance to be very high. So when we talk about confidence level, it has a relationship with the level of significance. And what is significant level? Significant level is the standard to which we are going to use, to which we are going to compare our result to. There is something we are going to compare the result to know if we are going to accept the null hypothesis or we reject the null hypothesis. Please, very important. So, however, in this particular, we are going to leave it for that standard stuff. Okay, let's select the residual. We select the residuals, and then let's look at the normal probability plot. We look at the normal probability plot. Okay. All right. How do you get what to select? I'm going to close this. I want everybody to be carried along, because we are now getting into we are getting into the main things proper. We are now pushing into the main things proper. So I want everyone to follow. Okay, now I believe you already know how to get to this place. Let me also start afresh. Anywhere here can do, you can. Anywhere here, just go to data, then come to data analysis. You click on it, this will show. Now once it shows we are in regression analysis, so we click on this and then say okay. Once we say okay, you now look at this. The Y range is the one you determine to be your dependent variable, and in these data sets, our dependent variable is revenue, because our revenue depends on the selling price per unit and the number of units sold. That's what our revenue depends on. So for me to get my Y, I will click here. I will click the first one. Hold Control, hold your Shift, and press the down arrow to select the entire range, to highlight the entire range. This data set is up to 5,000 something. It's more than 5,000. So to highlight the entire range, you click on the first one. Hold Control, hold your Shift, and press down. Press the down arrow. That way it selects the entire range, and that is how we get our Y range. Very, very important. Very, very important. Then we go to our X, which is the independent variable. And the independent variable here, we are talking about simple linear. So we are going to be using selling price per unit. We are going to be running a regression analysis, just one dependent, one independent. So I'm going to click on this, hold Control, hold Shift, and press my down arrow to highlight the entire range as well. To highlight the entire range as well, I'm going to go up. That becomes my independent. This now becomes my dependent. Now, having done that, the next thing I will do is I'm going to select the label. I'm going to click on the label. I'm going to do that, select that, and then the output range, let it be on a new worksheet. Let it be on a new worksheet. You can put it on the same worksheet. Why is because this one I already have stocks beside it. Let it be on a new worksheet. Now I'm going to click on just residuals, and then I need my normal probability plot. That is what we need to do, and that is how we can run our simple regression analysis. Simple regression. That is how we can run our simple regression, and we hit OK. Already is generating. It shouldn't delay, but maybe it's due to I have a lot of stuff opened on this particular system. I think that might be what is causing the delay, but it should be able to generate my regression analysis. It's not all, it doesn't always take time like this. Might be also the data, the volume of the number of the data sets, but it should be able to generate. If you have gotten yours, let me see in the chat box. If your own have generated, let me see in the chat box. Let me see in the chat box if you have generated your result. If your results have been generated by you, let me see in the chat box. If you have generated, type in the chat box, let me know. If you have generated yours, type in the chat box, let me know. Let me know. I don't know why it's taking this long. It should, from your own end, it should be able to generate. Let me get your feedback. Have you been able to generate yours? Drop it in the chat. Drop it in the chat, please. All right, this is what we have. This is what we have. This is what we have. Let me know from your side, have you been able to generate yours? That is our result, the summary output. We have our adjusted R, and we have our R square. Let me know if that is the same with yours. Let me get to know in the chat box, have you been able to generate yours? The T starts the P value here 0. That is . You can use any data set. You can generate any. You can generate any data sets. You can generate any data set. No problems. You can generate any data sets. Now, okay. Now we have this to be our outputs, the summary outputs, and we have this to be our residual, the probability output. These are results, the percentiles, the observation, the predicted. This is the predicted, like we have here, observation 1 to down, the predicted values. We have it down. Till the last data set. However, our focus will be on the summary to interpret what we have. Our focus will be on the summary to interpret what we have. Now, because of time, I'm going to pause here. I'm going to pause here. The interpretation, what we need to use to check is, for this, we need this R square. We need this in our interpretation. There is meaning to that. Also, our significance, the regression significance 0. Also, the coefficients, to use that for our equations. And then the p-values. The p-values, which is this, is the one we are looking at, because we have our y-intercept. Was not y-intercept, what do we call it? Our independent variable, that's the coefficients of the independent variable. So in that case, this is the result we have. Now someone is asking, okay, persons are saying I don't have the data set. Now let me head back to this place. I have dropped this data set in the scholarship group. I think I have dropped this particular data set in the scholarship group. I think I have done that. But if I haven't done that this night or tomorrow, I will endeavor to drop the data set for us in the scholarship group. However, you can decide to generate your own. You can generate your own data set by saying unit and then saying selling price per unit and then put in your revenue, whatever here, unit, this, and you use it to run your regression analysis. So that is how we can run the regression analysis. Now tonight, to wrap up tonight's sections, within some few minutes I'm going to be rounding up for this night section on regression. Next Friday we are going to be having a wonderful section to wrap it up with correlation and then interpret the data sets. Alright, now to run the multiple regression is still the same process. Please go with me. It's still the same process. You click here, select your regression and then say OK. Now here our y still remains our y. Our y is still the same. Here is where we will have to delete and then select the multiple range. Can select the multiple range, hold Control, hold Shift and press down. That is, now you see that I selected the 2. Before, in simple regression is only this, simple linear, but in the multiple linear I selected this because multiple. If I have other factors that influences the revenue, maybe marketing, adverts, maybe the adverts we did influences the sales, maybe let's say advert, online advert, TV advert, and maybe one-on-one marketing, whatever that influences sales, all factors that influences our revenue, we can add all of them. We can add all of them. When you hold your control, when you hold control and hold shift, holding both of them together, you press your down arrow, down, your down arrow on your keyboard. That is what you will press. You press your down arrow on your keyboard and then it will highlight all. So the same aspects, let me leave it on new worksheet. Let me select my residual, normal plots, and then I will now say OK. Okay, I think I made a mistake. I think I know where my mistake is. So here I'm going to put 6 and then say OK. What happens here is that the range of both dependent and independent must be the same. If it's from 1 to 1,000, the other one must be from 1 to 1,000. The range, not the value in the range. The range means from here down, not the value. The value can differ, but the number of the range, the total range must be the same. So I'm going to click OK. Victoria, I hope you got the explanation on how to select the range. That's the shortcut, because if you start to drag it down, that will be a long journey for you. So you just hold shift, hold control and press your down arrow. That way it will be done. We have been using that. That's why I started with the foundations, basics of Excel, those shortcuts, those stuff that we will do to enhance our efficiency working with Excel. That's why we started with that and explain those stuffs. So as we already know, this is loading, and once it's done, we will see our multiple linear regression results, and then we will save it. In our next class, interpretations will be done. Okay, as we wait for it to load. So please let me know if Victoria, did you get the explanation? Do you get the explanation? And anyone following us this night, feel free to drop any question. I see your charts. I follow charts. As I teach, I follow charts to ensure that everyone, your questions are being attended to live here. Okay, now the next thing I think I should be able to do this night before we wrap up, this ought to be a 1 hour 30-minute session. It ought to be a 1 hour 30-minute session. I want to use the remaining 30 minutes, the remaining 17 minutes thereabout, to explain correlation, so that on Friday we will head straight to practicals. On Friday we will head straight to practicals and begin to see diverse use cases of regression and correlation analysis, and then be able to interpret. Because if I didn't do that this night, on Friday I will still want to be explaining that, and that will delay me. Okay, now we have this result. I know why I did the previous one, and know why I did this like this. Now watch out here. There is something I want to show you before I proceed. Watch out here. The data set, in this data set, the first one the simple linear, I selected only from here down. I didn't include their header. I did it to show you that it's possible. Now that is the result we have here. So here there is no name. What Excel use as a label is the first one. There is no name. You see, that's the first one it uses as label. So that in a way might affect result. However, in this case, you see that our arrow square is high, and in this case we begin to see our p-values. These ones are 0. I will explain during interpretation, no need to be explaining now. And this is our lower, this is our upper, this is our lower, this is our upper for each of these what do we call it, for each of our variables. So we have this. Because of that, it affected our arrow squared and adjusted R, and here, but here you see that our arrow square is high, is close to 1, and this one also close to 1. The standard error is these observations. The observation here is the number of data sets in observation. That's 5,556. DF means degree of freedom. We are going to be looking at some explanations, and this is our normal probability plot. That is our normal probability plot. So this becomes the result for multiple linear. So to be able to know them, let me name it multiple linear, and then let me also name this simple linear. All right, so these are the two results we have from these data sets. Okay, now the next thing I'm going to do is I'm going to talk about the correlation analysis. I'm going to be talking about explain the correlation analysis, lay foundation. I'm going to be moving with kind of speed of light in explaining this. Now, what is correlation analysis? Now, correlation analysis, we will say, is a statistical method used to measure the strength and direction of relationships. Regression is to predict and to check relationship and to check effects. But this correlation is used to measure the strength and direction of the relationship between two or more variables. That's what correlation analysis does, to check if there is a relationship between variable A and variable B. If there is, how strong is the relationship? In what direction is the relationship going? Is it a positive relationship or is it a negative relationship? Is it a strong relationship or is it a weak relationship? That is what correlation analysis does. That's what we use it to do. It's a statistical method used to measure the strength and direction of relationship between two or more variables. So it has to determine whether an increase or decrease in one variable corresponds to an increase or decrease in another variable. It helps to determine that if there is an increase in variable A, will it impact an increase or a decrease in variable B? So with that is what correlation analysis helps us to achieve, to check the strength of relationship. How strong is this relationship? What direction is it headed? That's correlation analysis. And that is why when I teach this course, I put them under a common subject called relationship. I put them under a common subject called relationship. So let's quickly move to our next slide. What are the key concepts? The key concept is simple: the correlation coefficient. The correlation coefficient. It is the correlation coefficient that we use to determine the strength and the direction of the relationship. And because we assume that the data set is linear, we are going to be making use the correlation coefficient that we use is mostly referred to as Pearson correlation coefficient. Pearson correlation coefficient is mostly referred called Pearson. That's Pearson correlation coefficient. That's the name. I think I got it correct. Pearson correlation coefficient. When we run analysis, the name we also display. That's what we use, the Pearson correlation coefficient, because the data set is normally distributed. So now having done that, let's look at what that entails. Under correlation coefficient, when our correlation coefficient R, you can call it anything. You can call it Z, you can call it alpha, you can call it beta, you can call it beta, you can call it P, you can call it C, whatever is the R there is just a name. So the correlation coefficient R, if is equals to +1, that's a perfect positive relationship. In other words, it's a perfect positive correlation. However, it most likely will not really be excuse me, most likely it will not be 1, because analysis is built on probability, and probability is a mathematics of 0 and 1. If it's 0, that is certainty. You are certain that it will occur. If it's 1, rather, you are certain that it will occur. If it's 0, you are certain that it will not occur. However, probability is within 0 and 1. So that's why we have this, that +1 is a perfect positive correlation. However, in the practical world, there is nothing like perfect. That's why you hardly will see a relationship that gives you perfect 1 in analysis. But in theoretical aspect, as we are talking about it now theoretically, once is +1, that's a perfect positive correlation. The next one is once is -1. Minus there is what shows the direction. Get this. The minus shows the direction. The plus shows the direction. In other words, on the number line, the positive integers and the negative integers. So once is minus, is in the negative direction. Once is plus, is in the positive direction. Then the one there is what shows the strength. Is a perfect relation. The strength is 100% perfect. So 1 shows strength, while the signs shows direction. I'm explaining it in a simpler terms that you might not get elsewhere. 1 shows the strength, the signs shows the direction. And here, because there is no number, there is no signs, we have no correlation. Once is 0. Once there is no figure, there is no sign, there is nothing like -0. You can't have -0, you don't have +0. 0 is 0. So once the correlation coefficient is equals to 0, then there is no correlation. In other words, there is no relationship. There is no relationship. All right. We move to the next one. Types of correlation. Simple. We have the simple correlation is a correlation that deals with two variables, either one dependent and one independent variable. It deals with two variables. That is simple regression. It's analysis that check if there are relationship between the two variables. So simple correlation deals with two variables, variable A and B. When you are analyzing to check if there is any relationship that exists amongst the two variables, that's simple regression. That's simple regression. Then we have the multiple regression. Multiple regression. Once it's more than two variables, that's a multiple correlation. Regression have really entered my mouth this night. Simple correlation is a correlation analysis that deals with two variables. That's simple correlation. The multiple correlation is analysis that deals with more than two variables. That is multiple correlation. The next we are going to be looking at is strengths and directions. Strengths and direction. I'm going to be explaining certain things here. Very, very important. Some persons, some analysts use some measures, another measure. Some use another measure. But this measure is the one I always recommend, I always use. There are other ones, that one is also okay. I'm going to let us know tonight. Now, what this means is this. The strength of a relationship is strong when the absolute value of the coefficient. What we mean by absolute value in mathematics or in statistics or analysis is that the value must be positive. There is no negative absolute value. No. Once a value is in absolute sign, then there is the value, the output must be positive. So when the absolute value, remember in correlation coefficient, remember we said the negative sign is what shows direction. So the strength must be positive. The strength must be positive. That's why any value, any result you get in analysis must be subjected to the absolute value. Why? Because when a negative value enters the absolute, its absolute, it becomes positive. So a correlation seems to be, the strength of a correlation is said to be strong when the absolute value of the correlation coefficient is greater than 6. If it's greater than 0.6, remember it's within 0 and 1. Remember, we said it's within 0 and 1. If it's 0, no correlation, no relationship. If it's 1, that's a perfect relationship. So the strength is between 0 and 1. That's where the strength is, between 0 and 1. So a relationship is said to be strong if the absolute value of the coefficient, if the absolute value of the correlation coefficient is greater than 0.06. We say that relationship is a strong relationship. Some persons use greater than 0.07. Some use 0.07. So it depends on the one you are using. Some use 0.07. Some use this. So it depends on the one you want to use. All right. The next is moderate. Now, what is here is that if we consider the relationship to be moderate, we consider the relationship to be medium, if the absolute value of the correlation coefficient is greater than 0.04 but less than or equals to 0.06. I repeat, we consider the strength of a relationship as regards to analysis to be moderate if the absolute value of the correlation coefficient, remember we mostly make use of Pearson correlation if the analysis is a linear analysis and is normally distributed. If the absolute value is greater than 0.04 but less than or equals to 0.06. Now, some persons makes use of 0.03. Some persons make use of 0.03 and here 0.7. So some makes use of this range, greater than 0.03 but less than or equals to 0.07. It says to be moderate. However, the one I make use of is this. Once is greater than 0.04, once is greater than 0.4 and less than or equals to 0.6 is moderate. That's the one I use mostly when I analyze. Okay, now then we consider it to be weak if it's less than or equals to 0.4. That is the strength. Under the strength of the correlation, that is what you need to know this, because in our result, in the when you interpret your result, you will state the kind of relationship you have, whether it's a weak relationship, whether it's a strong relationship, or whether it's a medium or moderate relationship. You will have to explain it. All right. Now, having explained that or having stated that, the next we look at is direction. The positive correlation. Now, the positive correlation here means, listen attentively, get this please. The positive correlation here means that an increase in one variable will lead to an increase in another variable. When the relationship is positive, it means that an increase in one variable will lead to an increase in another variable. What we are having this night, we will say that the relationship between us this night is positive. As I'm growing, as I'm learning, we are learning. So if I experience a positive growth and that also is transferred to us, that also is seen in us, that is to say that the relationship is positive, because an increase in one variable leads to increase in another variable, in the other variable. So we say that it's a positive correlation. Is positive. Now the next one is a negative correlation. Now what does negative correlation implies? Is the opposite of positive. In other words, an increase in one variable will lead to a decrease in the other variable. Simple. Not too much English. In other words, we can call it an inverse proportional relationship. Negative correlation is can be seen or can be tagged to be inversely proportional, while positive correlation can be tagged to be directly proportional in our basic mathematics, in our O-level mathematics. So that is the aspect of strength and direction of correlation analysis. And this is where we will wrap up the night section. I will want to appreciate every one of us that made it to this night section. Thank you for being available, and remember to be also available on Friday. We are going to be having a wonderful section, fully practical, diverse use cases, different use cases, different data sets that we are going to be working with. Thank you very much, and do have a lovely night rest. I still remain your trainer, your facilitator, and your host, Mr. Franklin, the data analyst. Thank you, and do have a lovely night rest. Good night.